so we're going to see how electricity reach our homes. Okay, so let's say for example this is the source and the destination is the home. Okay, so we're going to take the to move the electricity from the power plant. So there are steps that we need to take. So for you to send electricity from the source to the destination, you need to increase the power or increase the voltage. Okay, we're going to step up the voltage using transformers so that we can transmit the electricity over a long distance. So that's why we're going to step up the voltage. Okay, so this is just an example of one transmission line. So in reality we do have many connected to each other. Okay, and when we send this we use this transmission line. After that we get to the transmission substation. So this is where we're going to distribute the electricity, and after distributing the electricity, so we're going to send it back to the transformers that we get close to nearby our homes. And those transformers, we're going to use it to step down the voltage, so then we can use it in our home, which is close to this value. Okay, I will show you an example that is much detailed. In terms of voltage, you can see this is the source and this one is the destination. So we need to send the information from the source to the destination. In terms of we need to transfer the electricity from the source to the destination. So what you see here, this is like to give you the range of, we start with 12 kilovolt. Okay, then we're going to go to the step up transformer, so then we can transmit the high voltage on the transmission line. So that's why you see the voltage is gonna go to 400 kilovolt. Okay, and then after this section we're gonna have a step down transformer. So we're gonna have in between, as you can see on the transmission line, we got two transmission lines, but there's more. But we're going to, after that we have a transformers that's going step down transformer that's going to step down to the original incoming voltage. So that's why you see we're gonna return back to this voltage. Okay, and the reason that why we stepping up the voltage, so that we can transmit it over a long distance, and also so we don't lose the electricity. So even if we lose the electricity, we can still get back the initial voltage. Okay, so that's why we stepping it up in such a way, even if we lose some of the voltage, we're still gonna get what we had at the beginning. Okay, then after getting to the step down transformer, then we're gonna go to the distribution lines that you see here. So in short, we should be able to get this electricity into our homes. So we're going to step down the transformer, the voltage again, so then our home we can receive approximately 200 voltage. Okay, and then you can see from the step down transformer and transmission line, our electricity meter unit is connected to. Okay, so later on we will see in details what is happening inside this area. Okay, and what is happening inside that area, this is what normally this part we'll find it inside the house. So they just to give you an idea. So we got our lines, okay. After the step down transformer, it's a transmission line that's gonna go to, we receive the electricity from and this transmission line, and then this is the electricity unit that we got here. So our electricity unit, okay, and from here we'll be able to measure the energy consumptions, okay, and move and use the electricity into our house. Okay, let's go further. Our main focus is on the electricity meter unit. This is just an example of meter unit. You can see the measurement that we get to be in kilowatt hours. So this is what we're gonna get. So the readings that we're gonna get into the LCD of the electricity unit, and we got our impulse. Okay, this is very important, and our main focus will be on the impulse. It's a LED that will be flashing, and then and similar to what we saw, this is just another example of a meter unit. This is the pulse LED, where we're going to wake, and then this is the value display into this LCD will be a kilowatt hour. It's what we're gonna get on this LCD. Okay, and to pay attention, you see this number. This is what we're gonna use later. This number means like how many times this impulse LED will flash. This is just to tell you, in this system, this LED will flash 1,600 times. That is how many times this is going to flash. Okay, in order to get 1 unit. So for us to know to get 1 unit, okay, only when the LED is going to flash for 1,600 times, or maybe it will be 1 kilowatt hour. Okay, so meaning this the number that you see here, it comes we will find it on each unit, electricity unit. You'll find this the number vary, but for this example, this is the number that you see here. So if I have to give you a meaning, okay, I'm going to recapitulate. So what we know is this is an LCD of our electricity unit, and the readings will be displayed into kilowatt. So it's gonna be something like this: kilowatt, this is kilowatt hour. Okay, and we got this LED impulse LED that will be flashing on and off. Okay, so in order to determine the number of unit, okay, for us to get 1 unit less, okay, into our meters, 1 kilowatt hours. So what we're going to get, it's determined by this quotation that you see here. Okay, the 1,600 number that you see here, that's what we're going to use. So it's 1 6, it's 1 6 impulse per kilowatt hour. So this number that you see here, that is how many times, okay? So how many times the LED is going to flash. So that LED that you see for the pulse, it's going to flash. Okay, so how many times the LED is going to flash it. So that's what you see here. The same number that you see, and this number will be equal to 1 unit. First we have 1 unit of the electricity bill. So this is equal to 1 unit. So if the LED flash 1600 times, then we're gonna get 1 unit 1 unit less. Okay, let me recapitulate what we just said. So 1 unit equal to 1 kilowatt hour. Okay, so we know that. Now if you have to find, for example, so here's the example that we had before. So we say that on our meters we find that the number of impulse per kilowatt hour is 1600. Okay, so in simple terms, this means that we have 1600 flashes, which is equal to 1 unit and 1 kilowatt hour. So that's what you see on the LCD of the electricity unit. Okay, this is another example, example 2. In this case, this is a different electricity meter unit. This is like saying that the number of impulse by kilowatt hour that we'll find on the electricity unit specification will be this. If we have this this number for in this case, okay, that means we're going to have 6400 flashes. So the number of flashes that the LED will be for us to reach to 1 unit, and we know 1 unit equal to 1 kilowatt hour. Okay, so this is just to give you an idea. In simple term, the LED blinks faster when you turn on more appliances. So meaning so just to tell you that this is the electricity meter unit, and this is the house where we have appliances inside. So the more appliances you turn on, the more the LED will be flashing. Okay, so the LED will blinks depending on the number of lenses connected to the activated into the house. Okay, so that's what you see here. So the more appliances you turn on, the LED blinks faster, and high power consume energy faster, and the LED blinks very rapidly. Okay, much faster. And if you, for this case, if you have low power, energy consumption slowly, and then the LED blinks very slowly. Okay, this is just to give you an idea. So how many blinks you're going to get at the LED. The more appliances connected, the more blinks you're gonna get, and the less appliances connected, the less blinks you will get, for you to get to 1 unit less. Okay, in short, the number of impulse per kilowatt hour equal to 1 unit equal to 1 kilowatt hour. Okay, and the number of impulse per kilowatt hour is actually the equal to the number that of LED flashes, or maybe we can say LED blinks. And just to emphasize what we saw, let's say electricity bill and then electricity unit. Okay, so as we said, 1 unit, and we said 1 unit equal to 1 kilowatt hour. Okay, that will be displayed on the LCD that you see here. So that's what we're going to trying to give you. And the kilowatt hour, in simple term, K it's for kilo, which is equal to 1000. Watt it's the W, which is the unit of power consume, and the H it's for hours. It's actually time. Okay, this just to give you an idea of the representation of what you get on the LCD of the electricity meter. And in simple term, the energy consumed equal to 1000 times the power consumed times the time. So I can even write it in this way. It's the kW that you see here.